So this is the week 9.3 project, and what we're going to do in this video tutorial is go through the process of making a record playback system by taking a very much a modular approach and breaking down the tasks of this larger project into smaller components. And then we're going to put it together and extend it, and you'll see how easy this is to do if you've designed your patch properly. So please download the week 9.3 max pat. As well as that, you're going to need the pan module.maxpat, the playback module.maxpat, and the record module.maxpat, because those are three abstractions that are being used in this file. Okay, so let's break down the tasks. I want to be able to record a sound into a buffer. I want to be able to play back that sound, set loop points, change the pitch of the playback, all of those things. And then I want to be able to pan that sound and control its placement in a stereo. Okay? So I'm going to break those into tasks. Oh, and I want not just to be able to do that with one sound. I want to have multiple instances where I can have separate buffers and separate playback controls and separate panning controls. So let's break it down, and let's first start with the simplest one, which is the panning module. So this is a pan module. This is an abstraction, and when I double click on it, we've looked at this before. It's an object which has a mono signal, a single signal coming in the first inlet, and a control value between 0 and 100, which controls the panning. And so the signal coming in is just distributed between the two outputs, the left and the right channels, using this as a control. 0 would mean the sound is completely on the left. 100 would mean the sound is completely on the right, and a value of 50 would mean the sound is centered. Right? So we can move the sound around in space. And you'll remember we use the square root to accommodate the fact that intensity perceptually is not the same as amplitude. You can't use linear amplitude when you're distributing a signal because it will not sound perfectly balanced if you do that, and we use the square root to do that calculation. Okay, so that's the pan module, and I actually just added in a little number display here so that we can move the sound and we can actually see the position in stereo space. Okay? If we wanted to, we could have this as minus 100 and plus 100. You know, you could scale it however you want. All right, so that's the pan module, and that's pretty much set, right? One signal comes in, one control to place it in stereo space, and two signals come out, a left and a right channel. Let's go to the record module, and this is a more complex abstraction, because you can see that it takes two arguments. The first argument is called buffer1, and the second argument says 2000. Well, if we open up the original, let's see if I can find the original record buffer in here, record module, rather. I open this one up. This is what I find. It says, oh, there's an input, so a message coming in. This is the start recording message. But then it says record tilde number 1 and 1. So this number 1 is the first argument. So inside this is a buffer name. A reference to a buffer name. And then it says one channel. And this delay is the delay time that's going to be set for the recording. So that when I bang a recording in here, what happens is that it actually starts the recording, and after the delay time, it sends a message here, which goes oh, it sends a 0 here. And the 0 goes out the outlet, and the 0 also goes into the toggle, which turns off the recording. Okay? So it's a little bit convoluted there, but basically we set a duration into this inlet, and at the end of that duration, the recording turns off. So it sort of automates the recording. What we don't have here is the buffer name. And in fact, I'm going to close this. The buffer names I put in an initialization patch up here. So I've got a buffer called buffer1, a buffer called buffer2, and a buffer called buffer3. And I don't know, we could add some more if we wanted. They're all 10,000 milliseconds, and they're all one channel. Why don't I just add 4, 5, 6? I don't know how many of these I might use. This could have been put into the record object as well. Some people would do it that way. I decided to do it this way to separate the buffers, just to show that they're completely disconnected from the record module. Okay, so there is something called buffer1, and the duration there is by default 2000, but if I pass a value in, that becomes the new recording time. And the input from my microphone goes into the second inlet. So I'm going to look in here, and there you can see the audio signal, which is going to be recorded. Okay, the output is just a button. So let's just see how this works. I'm going to click on this, and I'm going to talk for 5 seconds. And actually, you can see my recording coming in there, and it's done. Okay, so I got 5 seconds of recording, and when it was done, that light turned off, which is kind of nice. Okay, so that's the record module, and you can see how we've modularized it, and we're able to pass the buffer name inside the object. So, and you'll see when we start replicating this, why that is so useful and important. The playback module is also an abstraction, and it has an argument which is, we know now what it is. It's the buffer name. So when we open up this abstraction, we see that the buffer name has been put in here, and this is a groove object set to have a time stretch value of 1, so the time stretch has been disabled. We have a control here for the speed, which goes into a pitch shift message, which goes into the groove. And we also have the ability to start the loop, to turn the loop on, turn the loop off, and so on. And we just have a signal tilde 1 going in here. And we also have abilities to set loop points, start points, and end points for this. Okay. All right, so that's our playback module. So we've sort of modularized the essence of playback with lots of inputs into this module. We can see that I've got a button here, which goes into the first inlet to start the playback. I've got a button in here, which stops the playback. And then I've got the start and end times of my loop points in here. And then I don't have anything in there. What's that? Pitch shift, pitch control. Let's put let's just put a floating point number box in there, which is set to 1.0. This is not a particularly good interface, is it, for this, because it's a bit awkward to control it. A slider would be much better as a control of my pitch shifting. Okay, there's my 1. Okay, so let's just see what happens if I click on this. I'm going to talk for 5 seconds, and actually you can see my recording coming in there. So there's my recording. I'm going to talk for 5 seconds, and actually you can see my recording coming in there. for 5 seconds, and actually you can see my coming in there, recording coming in there, my recording coming in, talk, my recording coming in there. So this button basically stops the loop from playing back. So I mean, exactly the controls here probably could be refined a little bit, and think about what kinds of controls would be good. It's really nice if you can provide controls which give you sort of feedback as to what's happening, so that when you're in playback mode, the LED is highlighted, and when playback stops, the LED turns off. You know, like a play button that when you're finished playing turns off. That would be a nicer interface. For now, I've just used a couple of buttons to control this. Okay, so now I've got this all set, and let's just we'll just put some loop points back in here, and I will I'll also do some panning. 5 seconds, and actually you can see my recording coming in. 5 seconds, and actually you can see my recording coming in. 5 seconds, and actually you can see my recording coming in. 5 seconds, and actually you can see my recording coming in there. Okay, so the panning is working, the playback is working. It still needs some refinement. I didn't do the pitch shift, did I? Let's try this. You can see my recording clear. You can see my recording clear. Okay, so everything is more or less working in this sort of modular design. Now, why did I set it up like this? Well, one of the reasons I set it up like this is that I can duplicate this and make the changes to it very, very quickly because I basically created abstractions. So if I, for example, wanted to just say, well, what about if we duplicate all of this? So take all of this and duplicate it and bring it over here, and simply change all these names. So this is now buffer 2, and this is buffer 2, and this is buffer 2. And this then just hooks up to the outputs of my speaker. And this hooks up to the inputs. Okay? And I'm just going to set that. And I'm going to record now into this buffer. So, this button. So, this is a very different recording from the first recording I made. Okay? This is a very different recording from the first recording. This is a very different recording from the first. This is a very different recording from the first. This is a very different recording from the first. This is a very different recording from the first. Having too much fun. Okay, yes, this is serious work we're doing here. All right, so you can see how quick that was for me to make a second module out of that. I simply had to basically duplicate it and change 3 names so that they would use different buffer names. And if I wanted to make 6 of these, it would probably take me like almost 35 seconds to do. And I could basically duplicate, join them up, duplicate, join them up, duplicate, join them up. So you can see the advantages of having a modular design. Okay, so I'm going to get rid of all this now that we've got our modular design. And I want to talk about B patchers, which are a different form of a kind of like abstractions, but they allow you to embed patches inside a patcher. These work particularly well if you've got graphical objects that you want to embed. So this is what I'm going to do. I am going to take these three modules with their interfaces. I'm going to make a new object. And I'm going to I'm going to call this record, playback, I'm going to call it RPP. That's record, playback, and panning. Right? I'm going to call it the RPP object. And what I'm going to do is I'm going to copy that into this object. I'm going to copy all of that actually into this object. Okay. And I'm going to have two outlets for this object. For my right channel, excuse me, my left channel rather, and my right channel. Those are two signal outputs for this object. And then what I'm going to do is I'm going to replace this with a button. I'm going to put a button here. Actually, just going to put that into there. Oops. Okay. Whoop, whoop. Having trouble here. There, moving that out of the way. So that's my record start. And it's going to record for 5 seconds. I'm going to say a little message here. I didn't have my set buffer 1 here. In there. I'm just going to put a load bang. And I think everything I want in here is I'm just going to put just a that and that and that and speed. Okay. So I've made I put everything here, all of these modules in together, and I'm going to, whoops, I'm going to change that value to 5,000 just because it makes more sense to do that. All right, I've saved this as my RPP object. And what I'm going to do is I'm going to create a, I'm just going to select parts of it and I'm going to put some of this into presentation mode. Oh, I need an inlet into this as well. My inlet is for the recording. So I'm going to put my inlet right in here. Okay. So this is my recording inlet, and these are my two audio outlets. And within this object, I've got the word buffer 1, 2, 3 times in here. All right. So I'm going to save this again. And what I'm going to do is I'm going to select some objects to go into presentation mode. I'm going to select this one and this one, and this one and this one, and this one and this one and this one, and this one and this one, and that is it. And I'm going to go Command-Shift-P to put them in presentation mode. And there we have them. So there's my record start. Maybe I'll I forgot. Well, it doesn't matter. I'll put them in here. Start, stop, speed. Okay. And I'm not making this nearly as beautiful as you're going to make this. Don't need them to be quite this big, do I? And then I'm going to put a panel in. And we're going to go to my inspector and find some nice colors for my panel. There's a nice color. All right, I'm going to put this up in the top corner of this and go down here and send it to the back. Send to the back. And I'm going to put a border on, which is black, and which is 2 pixels in duration. All right, what I've done here is basically I've encapsulated all of the interface elements in this patch. And I go back here, and basically it's still set. I'm going to move some of those out of the way, but it's still set to have buffer 1 in a bunch of places. And just to be absolutely complete with this, I'm going to put the buffer in here. I know this is a kind of a duplication. I'm going to put buffer 1 5000. And I've got it in here. I know it's a duplication right now, but it won't be. I'm going to save that. Okay, now here's the tricky bit. I'm going to go into presentation mode so you can see what that looks like. Right? And it's going to be much more beautiful when you do it. And for example, I don't like this dial here. That number, that floating box there, that's got to be a slider of some sort. These buttons are not always right. I want to be able to see that I'm in playback mode. And yeah, things aren't lined up, and there's a lot of little things wrong, but we're just doing this quickly. All right, here's what I'm going to do. I'm going to save this RPP, and I'm going to make what's called a B patcher out of this. It's kind of like an abstraction. So every place in here where I have the word buffer1, I'm going to replace that with the word $1. There's $1, $1, $1, $1. Okay, I'm going to save that again, put it in presentation mode. And then what I'm going to do is I'm going to go to my view inspector window, and my inspector window is way over here. I'm going to set this so that it opens in presentation mode. Is that in here somewhere? Open in presentation, right there. So this particular patch called RPP will open in presentation mode when I open it. And it is set up to take one argument, which is going to be the buffer name. Okay, now that's a little bit complicated, but I've set it up now so that every place I had that actual buffer named buffer1, I replaced with a number sign 1. Okay, so let's close this patch up. And let's go back here. And let's get rid of all this. Get rid of that. Get rid of everything. And let's put a B patcher in. So I'm going to type N, and I'm going to type B patcher. What happens, you can hardly see this, but there's an area here that opens up, and it wants me to specify what file it should load into that patcher. And I'm going to go into my inspector, and I'm going to scroll down to where it says none, and I'm going to choose a patcher file. And I'm going to choose the file that says RPP and click open. And what happens now is that the RPP file has been loaded there. But I do not have an argument. Now, when we did abstractions, we knew how to put arguments in. We could just put our arguments in after the name of the abstraction. In a B patcher, we have to go down to where it says arguments, and we have to edit that, or just simply type in whatever we want. Buffer, I said bugger, that's not good. Buffer 1. Okay? Could be anything. Maybe I'll say buffer 10 just to show that it has nothing to do with what it originally was. Buffer 10 is the argument. That means in this B patcher, every place that buffer 1 or number 1 was represented, it's going to be replaced with buffer 10. Okay. And there we could see that it's set up with 5 seconds. And we need to now just connect our microphone into this object. That was the inlet. And our outputs here. Now, one of the things I don't like about this that I should have put in here is I don't have any meters in here. So I'm probably going to go and change that. So I've abstracted this. The actual buffer 10, it's called, is inside here. The record module is in there. The playback module is in there. And the panning module is in there. So let's just see if it works. Let's just see if this actually works. Just see. See if this actually works. So it's working actually quite well. How much work would it be to make a second module? Actually, let's go back into this module. I can right click on this module, go down to the option menu and open the original rpp.maxpat. So this opens up and I can edit it, go out of presentation mode, add my live.gain object in there, which I really am missing. Set that up so that it is horizontal. Whoops. Sorry. Set this live gain so it's horizontal. I might even change the name of it just to the long name. Let's just call it stereo out. And connect it in here so we can see the output. And Command-Shift-B to put that into presentation mode. Go into presentation mode. Give myself a little bit of space. This whole thing actually needs to be down just a little bit because we're not seeing the edges of it. Make it bigger. Let's just see if this actually works. It's talking all by itself. Let's close it now. Now, because it is a B patcher, it's kind of like an abstraction. When I've saved the original, now this has been changed. I just have to make my window a little bit bigger, and there it is. How much work would it be? Let's put this over here, out of the way. How much work would it be? Whoops. Sorry about that. To make another one of these. Well, it would take us about this long. Copy, paste, move it there, put the inputs in, put the outputs out, select it, change the buffer name or the argument to buffer 11 so it doesn't refer to the same one, duplicate it, attach the outputs. I'm just a little bit out of, just can't quite see it. And change the buffer name so that it says, say, buffer 12. So you can see how the modular approach to programming, how much it helps, how quickly and well organized things are. So not only can I, if I want to make changes, I make changes to all the existing copies, but you can see how quickly I can replicate this. So inside each of these modules are in fact 3 abstractions, and these 3 abstractions have now been put into a B patcher. And so I can get all of these working. I'm going to record. Let's record this one. La di da di da di da di da. And this is number 2 of my recordings. And these are all basically going to work. I can set loop points on all of them. And then they all finally shut up. Okay, if I wanted to make this into 8 of these modules, all independent and all running, it would literally take me about a minute to do that. So the point here is really just sort of seeing what kind of advantages come from modular design, where you basically build the individual component, possibly as an abstraction, possibly as a sub-patch, just as a patch, and then put them together, build the interfaces, and then if you want to create multiple instances of those, put them into a B patcher, and then you can replicate them very easily. And the B patcher basically, because it's in presentation mode, is just showing me the interface elements I need to access, and everything else is hidden away. Okay? So this is like, I would say, 75% of your assignment 10 if you take this approach. There are things about this that I don't like particularly, and there are things about this that I do. I like that little bang, that message showing the recording is finished. There isn't a control for just playing back the sample without the loops on, so that needs to be done. I don't like this floating point box. It's a little too awkward to control. This is fine. I don't mind that, and I like the fact that I've got a display. And I like the fact that I've got a stereo live.gain object in each of these, so I can actually see the volumes of each module as well as the overall volumes of them when they're all added together. Great. Good luck.